The apparatus are as below: steel, aluminium, brass, copper, nitrile glove, safety goggle, T-wrench, compression, mounting press machine, sample, mold release spray, phenolic powder, funnel, scoop, hand grinder machine, sample, grinding and polishing machine, polycrystalline diamond dilution, fume hood, etching chemical, and petri dish. The procedures for cutting: switch on the machine. Mark the sample according to size you want. Open the machine safety cover. Put the sample at the gripper slot and check the cutting position by move down the cutting blade parallel with the mark on the sample. Then, move both grippers forward to grip the sample and lock it up. The machine safety cover and push start button at the right side of the machine. Start cutting the sample slowly until finish. After finish, push the stop button at the right side of the machine. Open the machine safety cover and move the working table backward using the working table spindle. Then loosen the both grippers and take out the sample of the machine. Close the machine safety cover and switch off the machine. Molding. Switch on the machine. Spray the mold release spray on the ram surface and put the sample on that surface. Push and hold down the down button to move down the ram. Put in 1 scoop of phenolic powder in the ram using a funnel. Spray the machine cover with the mold release spray and close the ram until hand tight. Press the ram stop button to start the molding process. When the process has been complete, push and hold the down button to move down the ram. Open the cover slowly and put it on the cover holder. Push and hold up the button to move up the ram and take out the sample from the machine. Grinding. Turn on the water valve and wet the surface of the sandpaper equally. Before start the grinding process, see the sectioner of the sample first. Make sure that the sectioner is perpendicular with the position of grinding process. Then grind the sample one direction in a time with flowing the water continuously. Start the grinding process with the 240 grit of sandpaper and followed by the 360 grit, 600 grit and the 1200 grit for finishing. Turn off the water valve after finish the grinding process. Polishing. Switch on the machine. Bring up the polisher head by using the lever at the left side of the polisher head and lock it. Make sure you use the standard setting for polishing process, which using low spin and clockwise rotation for the polishing table. Press run or stop button to start rotating the polisher table. Use 1 micrometer diamond polycrystalline diamond suspension for the first stage of polishing. Hold the sample and start polishing process by rubbing the sample surface on the polishing pad with counterclockwise rotation. After done polishing the sample, rinse the sample with water and continue polish the sample using the 3 micrometer and 6 micrometer diamond polycrystalline diamond solution. After done polishing with all dilution, dry it using the dry air. Etching. Switch on the fume hood suction motor and light. Open slightly the fume hood safety cover and etch the sample in the etchant chemical. Close the fume hood safety cover and wait for a few seconds. Then open the fume hood cover slightly and bring the sample close to water valve. Open the water valve and rinse the sample equally. Close the water valve and fume hood safety cover. Dry out the sample using the dry air. After finish, switch off the fume hood and observe the surface of the sample using the metallurgist's microscope.
The purpose of etching process is to reveal the microstructure of the metal through selective chemical attack. It also removes the thin, highly deformed layer introduced during grinding and polishing. It is done by switching on the fume hood suction motor and light, Then open slightly the fume hood safety cover and etch the sample in the etchant chemical. Close the fume hood safety cover and wait for a few seconds. Then open the fume hood cover slightly and bring the sample close to water valve. Open the water valve and rinse the sample equally. Close the water valve and fume hood safety cover. Dry out the sample using the dry air. After finished, switch off the fume hood and observe the surface of the sample using the metallurgy microscope. The characteristic of martensite microstructure is that martensite has a lower density than austenite, so that the martensitic transformation results in a relative change of volume. The needle-like microstructure of martensite leads to brittle behavior of the material. Too much martensite leaves steel brittle, too little martensite leaves it soft. In conclusion, heat treatment affects the change in microstructure of a steel. For normalizing, the microstructure produced is fine perlite. For annealing, the microstructure produced is coarse perlite. Next, the microstructure produced for spheroidizing is spheroidite. For quenching, martensite will be produced after the process. While for tempering, tempered martensite will be produced in order to get these microstructures. There are few